So let's move on to a couple of examples. I've put on the handout some links to a website called howstuffworks.com, and this picture comes from that website. So an anti-lock brake system, or ABS system for short, is a system where when you drive a car, you know when you're on an icy surface, and maybe you don't know that yet, depends on where you're from, but when you're on an icy surface and you jam on the brakes, your car is likely to slip on the ice, and your wheels will lock up and you will not be able to steer. An anti-lock braking system mimics what you're supposed to do in that situation, which is to pump the brakes rapidly and lightly to bring the car to a gradual stop. And so the ABS system actually does that for you. So just by pressing the pedal down, if the wheels are slipping, as determined by a wheel speed sensor, then the system engages. And what happens is we have a pump to maintain the hydraulic fluid in the brake lines, and these valves open or close depending on what's happening with the wheels. If the wheels are not slipping, then a constant pressure is allowed to go through. And if it's on an icy surface, these valves open and close rapidly and bring the vehicle to a safe stop. So this is one example. So in this case, the pump and valve combination are the actuators, and the sensors are the wheel speed sensors. And again, the controller controls the valves to bring the vehicle to a safe stop. The second example comes from U of D Mercy, and this is our own autonomous ground vehicle. This has lots of sensors. I've only put a partial list down here, but we have wheel speed sensors, so the computer, and this is controlled by a laptop computer with some control algorithms to know what the vehicle's doing. It has LiDAR scanning, laser scanning sensor that scans for obstacles. It has a global positioning system receiver that allows it to know where on Earth it is. That comes in handy for one of the navigation challenges. And a camera to see the lines on the obstacle course. So basically this device, this system navigates an obstacle course, and there may be some students in here who have worked on it that could tell you a lot more about it than I can. But one example of an actuator that's on it are DC motors to actually drive the vehicle. Again, the controller monitors the environment and steers the vehicle to the destination while avoiding obstacles. Okay, so that's another example where we have controllers and actuators that are acting within an overall mechatronic system. Now, a measurement system is not the same as a mechatronic system. Most mechatronic systems do have measurement systems, but sometimes we might want to have a standalone measurement system. This is when we might be troubleshooting a part of the system out in the field. In that case, what we have is we basically just have the mechanical system with a sensor and some electronics, and now instead of trying to control it, we're going to have some way to measure that output. And so that's where the recording device comes in, whether that's some kind of a meter, an oscilloscope, it could be a paper tape, it could be a virtual instrument in LabVIEW. And that's what you'll be working on in your first activity, is a virtual instrument that records what's happening from sensors. Okay, so that's a measurement system. And if you're a mechanical engineer and you did your undergraduate degree here at UDM, then you had a measurement course in which you've already used such a measurement system. So let's end this here by letting me point you to some further things you should explore before you try to take the quiz. Again, explore the author's website and especially look at the video demo with the inkjet printer components. The textbook mentions this, but this is a very useful run-through of something that I may ask you either on the discussion board or in the quiz. So you should go through that video demo. The text examples that are given, this is of a mechatronic system, and this one is of a measurement system. Again, also very useful for illustrating the things that I mentioned. And finally, the last section talks about these threaded design examples. And what I'd like you to do is to view those videos and read those parts in the textbook. We're actually going to be coming back to those at a later time. And so it will help if you've gotten familiar with those setups. Again, this will give you, again, more examples of mechatronic systems. And it should help you in order to do any exercises in the exam. Okay, goodbye for